Now we have seen second part of instrumentation of mass spectroscopy. In earlier first part we have seen two components of instrumentation of mass spectroscopy. Now in this second part of instrumentation of mass spectroscopy we have seen remaining basic components of instrumentation of mass spectroscopy. Now we have seen third basic component of instrumentation of mass spectroscopy is mass analyzer, which is also called as ion separator. Positive ions get accelerated at the end of the bombarding chamber by applying the acceleration potential that is 2 to 8 Kelvin volt. Between the accelerating plates, some of the ions pass through slit and enter the magnetic field. As they enter the magnetic field, they get deflected in relation to their velocity, mass and charge. The lighter ions deflect more than the heavier. The mass analyzer should have the following characteristics. First characteristics, it should reduce the high ion current, and second characteristic, it should have higher resolving power. To distinguish very small masses, the mass analyzer is of two types. First is single focusing analyzer with magnetic deflection, and second is double focusing analyzer with both electrostatic field and magnetic field. Now we have seen first type is single focusing magnetic deflection. This is most widely used in mass spectrometer. It uses a permanent or electromagnet to sort the ions. The separation of ions is based on the principle of velocity. Focusing means focusing of all ions of same mass and initial deflection, but different velocities by employing successively electric and magnetic field. Now we have seen second type of mass analyzer is double focusing analyzer. In single focusing mass analyzer, the separation of the ions is based on the assumption that all the ions enter the magnetic field with same kinetic energy. This means that all the ions with same mass to charge ratio possess same velocity, but in practice this is not true since the ions differ in their initial energy. Thus, single focusing analyzer fails to discriminate between small mass differences because of small variation in kinetic energy. To achieve better focusing, energy has to be reduced before ions are allowed to enter the magnetic field, and increased resolving power can be obtained by using two mass analyzers in series. In this mass analyzer, the beam of ions passes through electrostatic field which focuses the particles of same kinetic energy on slit 2, which then serves as a source for the magnetic analyzer. Then it goes to detector through slit 3, which have seen in figure of double focusing analyzer. Now we have seen time of flight analyzer, which is the third type of mass analyzer. In this type of analyzer, the sorting of the ions is done in absence of magnetic field. It operates on the principle that if the ions produced are supplied with equal energy and allowed to travel predetermined distance, then they will acquire different velocities depending on their masses. In Bendix's time of flight mass spectrometer, a pulse of ions is produced in the ion source. An accelerating potential of the order of 2000 volt is applied to a grid in the form of a voltage pulse lasting micron second or less and is repeated intermittently, this positive pulse accelerates the ions into a long filled pre-dripped tube of about 1 meter, through which the ions move at their own velocities. Depending on the momentum, the ions reach the detector in order of increasing mass. Now we have seen four type of analyzer: quadrupole mass analyzer. In quadrupole analyzers, the sorting of ions according to their mass charge ratio is done without the need of magnetic field. The field is used to modify the motion of the ions so that only those ions having a narrow range of velocities or masses can be detected. Now we have seen fourth basic component of instrumentation of mass spectroscopy is the mass detectors. Three types of ion detectors are generally used in mass spectrometers, that is Faraday cup, an electron multiplier, or the photographic plate detectors. Now we have seen first type of detector is Faraday cup collector. It is a simple and least sensitive detector used in mass spectrometers where extreme sensitivity is not needed. It consists of an insulated conductor directly connected to an electrometer amplifier. Its cup shape reduces the chances of escape of secondary electrons liberated by the ion impact. Now, second type of detector is electron multiplier. The operation of electron multiplier is similar to that of convention photomultiplier detector used in UV visible spectrophotometer. It consists of the primary cathode optimized for the detection of ions rather than photons. The sensitivity of this detector is 1000 times greater than that of Faraday cup. Now we have seen third type of detector is photographic detection or photomultipliers. This detector system is more sensitive than any other detector because the photoplate integrates the ion signals over a period of time. The photoplates are processed by the usual photographic technique and read with the aid of densitometer. Photographic detection is used effectively for high resolution in double focusing spectrometers. Now we have seen fifth and last component of instrumentation of mass spectroscopy is a vacuum system. Since the ions must travel a considerable distance through the magnetic field to the collector and also to avoid ion scattering and background, a very low pressure of the order 10 to the power minus 6 to 10 to the power minus 7 millimeter of mercury must be maintained in the mass spectrometer. Loss of ions from the sample may take place due to collision with molecules of atmospheric gases, resulting into superior result. Most of the vacuum systems use combination of mechanical and oil diffusion pumps to produce required vacuum.